Dear colleagues, dear friends, I'm glad to meet you. And for those who did not attend my dissertation defense, I would like to make an online version of it. So, today I invite you to talk about the theoretical aspects of price transmission, a case of joint production. Farm to retail price transmission process is defined as the percentage change in retail price of a product due to a 1% change in the corresponding farm price. Price transmission provides insights into market efficiency, consumer welfare, producer welfare. Increasing price transmission increases market efficiency. Perfect price transmission contributes to consumer gain when producer prices decline and to producer gain when consumer prices increase. And certainly this topic has drawn attention of scientific literature. Empirical studies tend to detect the incomplete price transmission to analyze price dynamics and to test for adjustments to policy measures. Apart from empirical research, there are a number of studies working on theoretical aspects of price transmission. Theoretical studies tend to define factors impacting the value of price transmission, to assess the impact of each of these factors on the value of price transmission. Such research allows us to define which factors make sense to influence and in which way in order to bring price transmission to a desired level. Both empirical and theoretical studies usually estimate price transmission based on a single output framework. Theoretical studies traditionally assume a production process where two inputs are used to produce a single output. However, cases of multiple outputs are very numerous. Cow, for example, supplying bones and meat, or sheep supplying wool and mutton, or a dairy industry producing butter and skim milk powder, or cheese and whey. And dairy processor every day has to make a choice: which good should he or she produce, butter and skim milk powder or cheese and whey? If a dairy processor is able to apply market power, then he would certainly be interested in producing a product at which market he may apply the highest degree of market power. Consumer would like to choose a product which price transmission is higher when prices on producer level decline and is lower when prices on producer level increase. So both processors and consumers are interested in absolute values of price transmissions of dairy outputs. Dairy processors might be interested whether price transmission of multiple outputs are interdependent. In other words, if something happens on one of the output markets, does it impact price transmissions of other outputs? And if yes, then how? Consumers are interested to which extent market power is transmitted to each of the multiple outputs. And we, as researchers, are interested whether we may use a theoretical framework of a single output to estimate price transmission for multiple outputs. So, to be able to answer these questions and maybe some others, we decided to extend a theoretical model of a single output to the case of multiple outputs. And we chose the model by McCorson, Morgan, and Reiner for this purpose. The aim of the study itself, of McCorson's study, was to determine the factors impacting price transmission and to assess the contribution of each of these factors to the side of price transmission value. For this purpose, McCorson builds a partial equilibrium model where output quantity is equated with output price to form the output clearing condition. Profit maximization condition is used to incorporate the condition of imperfect competition into the model, and he also they have agricultural input, supply and demand functions, and material input supply and demand functions. They use it to model the inputs clearing conditions. Results of the model of this model indicate that the impact of the following factors, such as market power, returns to scale, share of agricultural input in total inputs used, elasticity of substitution between inputs, elasticity of supply of material inputs, and retail elasticity of demand, form the value of price transmission. The impact of parameters on price transmission is unambiguous, except of two parameters such as retail elasticity of demand and elasticity of supply of material inputs. The impact of these two factors is ambiguous, and let us now talk a little bit in more detail about that. Impact of agricultural input share on price transmission is unambiguous, as we already mentioned. So, increase in agricultural share increase price transmission. If there would be only a single agricultural input, then perfect price transmission would be equal to 1. But since we have two inputs in the model, agricultural and material input, and their shares are equal, so the share of each input is equal to 0.5, then a perfect price transmission in this case is also 0.5. In other words, perfect price transmission should be equal to the share of agriculture, or of the impact of the input, which impact we are actually estimating. So the higher will be the share of this input, the higher is our price transmission. Impact of market power on price transmission is unambiguous, so that the increase in market power, this red line is the increase in market power, leads to the definite decline in price transmission value. The impact of returns to scale on price transmission is also unambiguous. The increase in returns to scale leads to a definite increase in price transmission value. Impact of elasticity of substitution on price transmission is unambiguous. Increase in elasticity of substitution between inputs lead to a definite increase in price transmission value. However, there are still two factors, which I already mentioned, which impact on price transmission is not so clear. It is unambiguous, we say, so that increase in the elasticity of retail demand, we show it with the blue line, leads to the increase or to the decrease in price transmission depending on the interaction with returns to scale parameter. So that in first case I showed the case for constant and decreasing returns to scale. This case contributes to the decline in price transmission when retail demand increases, and the case of increasing returns to scale contributes to the increase in price transmission when retail demand increase. The impact of the elasticity of supply of material inputs is even more complicated, so that it depends on the interaction of four parameters simultaneously. In case of constant returns to scale and elasticity of substitution of between agricultural material inputs greater than elasticity of retail demand, increase in elasticity of supply of material inputs leads to the increase in price transmission. The second case, when returns to scale are decreasing and retail demand is inelastic, price transmission also increases. But in case of increasing returns to scale and elastic retail demand, price transmission is decreasing when elasticity of supply of material inputs increase. So, These are major results of Macpherson, but the most important result of Macpherson was that he proved that economies of scale may offset the impact of market power. In other words, it formally means that price transmission may be complete even in imperfectly competitive environment if certain conditions are held, such as frequency scale are increasing and demand and industry has a log linear demand function. This model of Macpherson, working with theoretical aspects of price transmission, was chosen to be extended for the case of multiple outputs, such as butter and skim milk powder as goods complements, or cheese and whey as goods complements, and butter and cheese as goods substitutes in production. We, however, split this task into two parts, estimating as a first the impact of goods complements in production on price transmission, such as, for example, butter and skim milk powder. We did it because when we start the model of goods substitutes in production, such as butter and cheese, we should include the impact of goods complements in production, such as butter and skim milk powder, if this impact matters. However, if it does not matter, then we will not include it, and we would use the conception of a single output to estimate price transmission for goods substitutes. How would we decide whether the impact of goods complements in production matter or not? We first of all estimate price transmissions of goods complements in production and achieve the aggregated price transmission of butter and skim milk powder, and in case this aggregated price transmission of butter and skim milk powder is equal to a price transmission of a single output, then we decide that the impact of goods complement does not matter. But in case if price transmission of butter and skim milk powder, aggregated price transmission for these two goods complements, is different from a single output price transmission. In this case, we decide that price transmission of goods complements matter and it has an impact on price transmission. And in this case, we will include the impact of goods complements in production in the modeling framework for goods substitutes in production. So, let us first of all define what do we mean by the goods complements in production. Goods complements in production represent a set of multiple outputs produced in fixed proportions out of a single production process, so that the increase in one good cannot take place without the increase of another good. Prices of such goods are made on the unit of measure of these products, while global cost is made on the unit of measure of global production. We assume a number of milk processing firms which produce two goods complements in production using two inputs such as agricultural and material input. And we also assume a linearity of production technology because milk might hardly be substituted with material inputs in butter production. We assume that there are three agents on the market, such as producers, processors, and retailers, and processors in our case apply market power against retailers. So now we come back to the theoretical framework as in Macpherson, but now on the output level you see two demands for two outputs, so that we do not anymore have a single output, but we have two outputs which are jointly produced goods and dependent goods from the side of production, but are totally independent on the side of consumption. So they are both goods are traded to the independent markets, and they have their independent demand functions and independent prices, therefore. Or, well, prices are not totally independent, but demand functions are independent. So, and you may also see on the output level not a production function, but a joint production function now, where two outputs Q1 and Q2 represent the transformation function. We also include market power into the modeling framework by the means of profit maximization condition, and in profit function you see the joint costs are subsumed from the joint revenue. Input markets stay the same as in Macarson's model, and we also introduce a throughput separation condition using the outputs fixed relationship and the transformation function. So, to which results do we come? Our model indicates that price transmission of a joint output is not equal to price transmission of a single output. This is first. And also moreover, I would say that the aggregated price transmission of aggregated goods is not equal to price transmission of a single good, which formally means that when estimating price transmission for goods substitutes in production, the properties of goods complements in production should be considered in the modeling framework. As we already discussed about the Macarson model, in his study he proves that perfect price transmission of a single output should be equal to the agricultural share of in the total input used. Our model results conclude that perfect price transmission of a joint output is not equal to the share of agriculture. Perfect price transmission of a single output is bigger than perfect price transmission of a joint output. And if we say that our agricultural share is 0.5, then perfect price transmission of a single output is 0.5, but of a joint output is 0.3. Which means that empirical studies should notice that the estimated price transmission of a dairy product contains the impact of jointly produced goods, so that the perfect price transmission of butter should be lower than perfect price transmission of a whole milk packed. Our model results indicate that price transmissions of jointly produced goods are not equal between each other. They are different, and they depend on the elasticities of retail demands of those goods. In case they are equal, then price transmissions of jointly produced goods will be also equal or identical, but this is nevertheless rarely the case in reality. However, in theory we may assume this outcome as well. Just an addition, elasticity of retail demand of a first good impacts not only price transmission of this first good, but also price transmission of the second output as well. And the other way around, retail demand elasticity of a second good impacts price transmission of a second good, but as well of a first jointly produced good. Our model results indicate that market power is transmitted in relative terms equally to both markets of both jointly produced goods, and returns to scale are also transmitted in relative terms equally to both markets. I would like to mention here that I'm talking now not about the absolute values of price transmission, but about the relative changes. So market power and returns to scale contribute to the equal relative changes in price transmissions of jointly produced goods. And we were also interested in the impact of all of the parameters which Macorison estimated on a single output. We were also interested whether these parameters have same or different impact on the jointly produced outputs. And we detected that yes, these parameters, not the impact but the direction of the impact of these parameters on single output and on jointly produced output is the same. For example, if market power decrease price transmission of a single output, it also decrease price transmission of a joint output. And if returns to scale, for example, increase price transmission of a single output, it also increase price transmission of joint output, and so on with the rest of the parameters. And coming to the end of my presentation, I would like to say a couple of words about the outlook of the research. And certainly the obvious extension of the model would be to extend it for the case of good substitutes in production. Apart from that, it might also be interesting to make an empirical application of the model, or to extend this model to different types of market structure. So now I have to thank you very much for your attention. I hope you found something new or maybe even something interesting among my discussion. Hope to see you somewhere. Wish you all the best, and thank you in advance for your congratulations.